So good day, everyone. Our next topic is about arrays. So let me ask you one question first. So suppose I assign you to declare three variables for three people. So how do you create this three variables? So do you start with person and then person two and then person three versus starting with the person then one and two, or you start with one and then two and then three? So these variables, person, person one, person two, and person three are what we call as scalar variables. So when we say scalar, it is a variable that has only a single value. So for instance, as you have seen in the example previously, the person has only a value of 100. So however, there are many things that require a set of related values. Okay, so for example, coordinates x, y. It has two values. Vectors that say require three, or you have a text. And a text requires a long list of characters in a specified order. It does not only contain one character or two characters. In order for you to create a text, you have to combine several characters, or let's say letters, in order to make a meaningful one. Okay, so also, another example is a spreadsheet na data that is often a long list of numbers. Okay, so one of the frequently arising problem is to handle similar types of data. So for example, if the user wants to store grades for a set of 100 students, so then you want to perform operations on grades such as rank them in ascending order, compute the average, find the median. Okay, so you were able to compute the average before in our previous na discussions and also in previous na modules that I have given by simply adding each value into a cumulative total as each value is entered. Okay, so here's the source code that I have given before. So this source code returns the average of a set of grades. So let's see the expected na output of the code first, or what it does. So first, let's say you ask the user to enter number of students, let's say three. You enter three students, and um, then the program will prompt you to enter grade for each na student, and later on it will return the average. Okay, so what if um, you have 95 na students? So your program will also loop 95 times in order for you to enter the grade of each na student. So here's the source code for that. So you have variables grade, sum, and then the average with a float data type, and then you also enter the number of students as well as the counter for our loop. Okay, so this code, you simply have to enter the number of students, then you scan the value and store it in in the variable num students with a type integer. Okay, so while your counter is less than the number of students that have entered, so you you prompt the user to enter the grade of the student, and that grade will just be cumulatively added to sum. Okay, and then you simply increase the counter and until such time that it is your condition will be false. So later on, after you have looped through all the student grades, you the sum of all those grades will be divided by the number of students in order to find the average. Okay, and then you simply print the average. So what's a bit taxing about this code is, suppose you have a lot of students. We are a large class. For example, in our class we are 62, right? So, and then you, in this kind of format, you are going to enter the grade one by one. So what happens if I suddenly had a mistake in the middle, right? So I have to repeat it again. So that this kind of technique will be a bit tedious. So now another problem is that, let's say you have another task to rank those grades in ascending order. So you quickly realize that you cannot perform such an operation until each and every grade has been entered. So therefore, using the techniques described previously, you would read in each grade and store it into a unique na variable. So as in declaring 100 variables for each na student. Okay, so now after all the grades have been entered, you can proceed to ranking them. So this can be done by a series of if statements to compare each of the values to determine the smallest grade, then the next the smallest grade, and so on until the maximum grade has been determined. So now, after you're done doing it, you will quickly see how large and complex your program is. So this kind of method or technique is rather tedious and impractical. Okay, so all is not lost. So arrays come to the rescue. So how do we define arrays? So we can define a variable called grades, so which represents not a single value of a grade. So do you remember what the variable that has only a single value? So if you remember, a variable with only a single value is what we call a scalar and a variable. Okay, so in contrast, the arrays is a variable that represents not a single value, or in such case, not a single value of a grade, but an entire set of grades. So spec says that defining arrays is that array is a continuously allocated non-empty set of objects with a particular member of object type. So in real language, it's just a bunch of things of the same type, right? Okay, so of the same type, or values with that are related. So each value in the array is like a real variable. So, but all you need to know is that where the array begins or starts. So, and then, for example, you have 65 students. So, where do you, who's in, where does your, at which student would you begin with the arrays? And then what type of data is in the array? So, is your array an integer, or is it a double, or is it a string or a character? So, and then how many elements are in the array? So, how many, let's say you have an array of grades, and how many student grades do you need to enter, or do you need to store? Okay, so let's say instead of declaring variables, individual variables such as grade 1 or grade 2 and grade 100, or like the first example that we have shown is that person 1, person 2. Okay, so we declare one array of variables such as grades to store marks of 100 na students. So these members of the array na grades are what we call as elements and can be individually selected by their position within the array. So you will understand this later as we go on. Okay, so the elements of an array or what we have mentioned before is the members of your array. So that those are your elements. So are conceptually arranged one after another in a single row or column if you prefer it. So here's how we visualize it. So suppose we have an array in grades, and you have the elements that are arranged one after another. So let's say this is your element one or grade one, or and then grade two, third, fourth, fifth. So yes, so you have five members of the grades na array. And we have mentioned before that um, uh, the elements of an array can be individually selected by their position. So meaning, if we want to access the first na element or the first na grade of the student, let's say, so you base on its position. So the position in the array. So first student, so meaning you select this one. If you need this, the grade of the second student, you select this grade, okay, or the grade on this that is second on the grades na array. Okay, so example, so imagine there are only 5 students in a class, and they get the following scores on the exam: 57, 85, 97, 16, and 82. Okay, so what we want to do is to uh, create a program to compute the grade na statistics. So let's say you enter all the scores, 57, 85, 97, 16, and 82, and it will show the average. Let's say it's 61.4. So this scores in the grades array are visualized like this. So you have the first grade 57, and then 85, 97, 16, 82 that are conceptually arranged one after another. All right. Okay, so as with other declarations, array variable declarations include a data type, a variable name, and it should end in a semicolon. So like any variable, you have to declare it. Okay, so and in addition, an array has a length that are enclosed in square brackets. Okay, so as we have mentioned before, what we need to know is the where the array begins, and then what type of array it is. So that is the data type. Now we also have to specify how many elements there are in the array, and that is the length. All right, so this is the general syntax for declaring an array. So the type refers to the data type, or integer, float, double, or char. Okay, and then the name or the identifier, and then enclosed in the square brackets is the length or the number of elements in the array that is specified. So the length should be an integer that is greater than 0, and the type can be any valid scene data type. Okay,